In this video I want to discuss something called Descartes' rule of signs. In order to talk about that, we need to talk about what variation in sign means. So if you look at a polynomial, a variation in sign simply just means that one term is possibly positive and the very next term is negative, or vice versa. We've got a negative term and the next term would be positive. Okay, so let's talk about how many variations in sign we have from left to right here. So we go from a positive to a negative here, but then we still stay negative for the next term. Then we go from a negative to a positive, and then it stays positive again, and then our last one goes from a positive to a negative. So there are three variations in sign in this problem. So in order to figure out, in order to use Descartes' rule of signs, we need to be able to figure out the variations in sign. So what Descartes' rule of signs tells us is that if we look at a polynomial, we can determine the possible number of positive real zeros. So how many times this graph would cross the x-axis at a positive x value by just simply counting the variations in sign of the function. Okay, so I'm going to go ahead and do that. So the possible number of positive real zeros in this case would be how many times it varies in sign. So I'm gonna follow through here. It's positive, it's still positive, then it goes to negative, and then it stays negative. So there's only one sign change, and therefore there's only a possibility of one positive real zero. Now, it does say, I'm going to continue on there, that it's that number or is less than that by an even whole number. So what it means is whatever the number, so it's going to be 1 in this case, or what that means is an even whole number less than that means keep subtracting 2 from that number until you end up at 1 or 0. Okay, so let's say that there were 5 sign changes. Then my options for possible positive zeros would be 5 or 3 or 1. I want to keep subtracting 2 until I end up at 1 or 0. Then we can also check the possible number of negative real zeros by counting the number of variations in sign of p of negative x. So first I have to figure out what p of negative x is. And the way you do that is we're going to plug in negative x for every single one of these x's here. Okay, I'm going to replace x with negative x. And the shortcut for this is that if the x is an even power, the sign of that term won't change when I replace it with negative x. So if I plug in negative x for 3x to the 6th, it's still going to be 3x to the 6th because I have an even number of negatives multiplied together, so that's not going to change my sign. But the very next sign would change because I have an odd number. Okay, so I have x to the 5th. If the exponent is odd, the sign in front of that term will change when I replace x with negative x. So the next one will change as well because it's an odd power, so that's going to be minus 3x to the 3rd. And then this is x to the 1st, so again it's odd, so that's going to change that sign. It's going to become plus x. And then your constant will never change. It will stay the way it is. And then I'm just going to count my number of sign changes. So in this case I have 1. Still negative, 2, change back to negative, there's 3 here. So the possible number of negative zeros, is going to be that number of sign changes, which would be 3, or keep subtracting 2 from that number until you end up at 0 or 1, so it's going to be 3 or 1.